the fastest thing we know of in the universe. It's also the universal speed limit. According to the equations of Albert Einstein, matter cannot exceed the speed of light. That speed limit is set at exactly 299,792,458 meters per second, or roughly 186,000 miles per second. And it's because of this that our options for space travel are severely limited. Even traveling at 99% the speed of light, the highest speeds physically allowed for matter, it would still take years or decades to reach distant galaxies. Science, particularly quantum physics, does offer up some potential workarounds, with quantum entanglement seeming to bypass the speed of light as two particles appear to communicate instantly over vast distances. But there are so many unknowns here, and some researchers argue that quantum entanglement isn't really breaking the speed of light anyway because, weird as it is, no true information is passed between the entangled particles. For today's video, we'll be working from the more traditional understanding of light speed. The speed of light is set, but the size of the universe is anything but static. Back in the 1920s, scientists were shocked to discover that the universe was expanding. They observed that light from galaxies that reached Earth was being redshifted, meaning they were moving away from us and each other at high speeds. More recent Hubble telescope measurements further confounded the problem, though, as it was shown that not only was the universe surely expanding, but that its expansion was also accelerating. Not only that, but it was expanding far faster than what had been previously thought possible. In fact, today's research even suggests that we could need completely new physics to explain what we now understand about how the universe behaves. For today's question, though, the problem is this: if the universe is expanding, then where is its edge? Let's start with the observable universe, as that, by definition, has a defined edge to it. The universe has been around for about 14 billion years, and during this time, only so much light has had time to reach us through the vastness of space. Given the rate at which the universe has expanded since that light started traveling towards us, the farthest objects we can now see, the edge of the visible universe, is estimated at 47 billion light-years away. So if we simply wanted to know how long it would take light to reach the edge of the visible universe, the answer would be 47 billion years, the same time it's taken the furthest light we currently know of to have reached us today. The problem, however, is that the edge of the observable universe is not the edge of the entire universe. We know there's more of the universe that we still can't see because the light hasn't had enough time to travel to us just yet. So where's the edge of the entire universe? This question is a lot more complicated to answer for a variety of reasons. Chief among them is that we don't know that our universe even has an edge. When we look out into space from Earth, it appears as though we're at the center of the universe because all the light is coming towards us from all directions. That's only an illusion, however. And if you were to be somehow teleported to the edge of the universe, or to anywhere else in space, it would still seem as though wherever you were positioned would be the center, in much the same way. Astrophysicist Paul Sutter uses the analogy of ants crawling over a beach ball to explain the shape of the universe. The ants are galaxies, and the beach ball is the universe, which expands as it's filled with air. The beach ball is round and doesn't have an edge nor a center, because the surface of the ball itself is the universe. Depending on whether or not you subscribe to the various multiverse theories, the edge could exist in another dimension. But as far as we know, or as far as we can predict, the universe may not have an edge or even need one. But even in the event that there is an edge, when would light reach it if we shot a beam from Earth? As it turns out, never. That's because the rate of expansion in the universe is believed to have gotten so fast that it outpaces even the speed of light. The edge, if there is one, is constantly moving away from us at speeds faster than the speed of light, and would therefore expand farther and farther away the closer light got. Matter in the universe can't exceed the speed of light, but the universe itself, it seems, can. In the universe, then, the only feasible way to reach the edge is to travel faster than the speed of light, which, for light, is naturally impossible. But wait, doesn't that mean that the apparently universal speed limit has been broken? Well, yes and no. It may seem like the universe itself is breaking this apparently unthinkable rule in its own expansion, but at no point is matter itself traveling faster than light. Only the space around it is. The empty space between matter simply doesn't follow the same rules and so has no limit. In essence, the well-peddled theory about traveling through space using wormholes follows the same logic, just in the opposite direction. Wormhole travelers aren't going faster than the speed of light, they're simply compressing and thus shortening the space between 2 points. In this case, the space between any 2 points is always inevitably extending. And to flip the idea on its head just one more time, this not only means that light will never reach the edge of the universe, but also that light from the edge of the universe will never reach us. There are whole galaxies filled with stars and planets that lie forever beyond our field of vision given the universal speed limit of light. There are whole regions of the universe that we will never see or explore, potentially even bigger and more expansive than everything we do at least know about. For all we know, there's extraterrestrial life all the way out there, but we're too far away from each other to ever communicate or even know of each other's existence. If we're talking visible universe only, then it would take around 47 billion years for light from anywhere to reach the edge. If we're talking total universe, then we'll likely never know for sure. The edge of the universe could well be a mystery that remains forever unsolved, because unless we can one day utilize the same cosmic trick that the universe itself employs to bypass the universal speed limit, then nothing, not even light, will ever get even close. And that's how long until light reaches the edge of the universe.